This is the second of a short video about ELEC120 to clarify some common questions I've been asked by people. So this is looking at a January 2012 paper. First up, I'm going to talk about this question here, which is the triangle question. So this is 1C. You can split this up. Basically, it's a geometry problem. So it all comes down to sines and cosines of 30 degrees. What I want you to be able to tell me is what direction the charges will move relative to each other. So essentially, negative charges will move towards positive charges and like charges will repel. These are the fundamentals of electrostatics. I'm just going to say as well that in the resit paper there's a question with 4 charges. I'm not going to ask you anything beyond 3 because it just becomes a mathematics problem rather than an electrostatics problem. I also wanted to talk about 1D part 3. This one asks you about a capacitor being discharged through a resistor. This is an RC circuit and it's looking at the time constant, and this is actually covered in ELEC142, so it won't be in the exam for ELEC120. Going on, I'm going to talk finally in this video about 1E. So 1E is talking about this function for the electric field strength with respect to R, where R is the distance. We have covered this in lectures, but I haven't explained it in this type of way explicitly. So what this is all related to is that, and we looked at this when we derived the expression for the value of a capacitor, is that the electric field strength E is equal to the derivative of the voltage or the potential with respect to the distance. Remember, this distance, we quite often use R because we're dealing with circles in these sorts of problems. But this is the fundamental relationship which this whole problem is based on. That's the electrostatics involved. You're then actually in this question asked to find V. You've got an expression for E with respect to R. So what this means you need to do to solve this is you just need to integrate, and we've got that negative because we've got a negative over here, is we need to integrate E of R with respect to R, and that will give us V. And that all ties into how you've got an expression for E of R, so you integrate it and then you put the values in and you evaluate it where you're asked to. So I'm not going to ask you to do this sort of integration because it's just testing your integration skills rather than your electrostatics, but it is important that you understand how you would go about solving a problem like that. And again, it's due to this fundamental relationship, which we covered in a lot of detail when we derived the expression for a capacitor. So have a look in your lecture notes and you will see we've used it in a much more applied sense rather than this abstract mathematical sense.